So appreciation, sometimes referred to as compound interest, is the growth by a percentage amount over a period of time. So compound interest refers to a financial, but you could have something that is appreciating with regard to its size over a period of time at a particular percentage per year, per month, per day. So step one, when we're appreciating or working out the compound interest, is we're going to start off with 100% because that's our whole, and we're going to add on our percentage increase. We're then going to take this new percentage, which will be greater than 100 because it's an increase, and divide it by 100 to change it to a decimal, and our decimal will be 1 point something. We're then going to take that decimal to the power of time, and that time could be in minutes, seconds, years, months, and then we're going to multiply it by the original amount in order to work out what our new value would be after that period of time. If the question asks us for what that increase is, we then need to subtract the original amount from our final amount to work out what the increase is. So in our example, Dave invests £560 in Cloudsvale Bank. Their annual rate is 2.5%. And we want to calculate the compound interest after 4 years. So using our new method, we're going to start off with 100%. And we're going to add on our annual rate, and our annual rate is 2.5%. So we're going to add on 2.5%, giving us a new percentage value of 102.5%. We're then going to change that into a decimal by dividing by 100. So 102.5 divided by 100 gives us 1.025. And then we're taking that decimal of 1.025 and we're putting it to the power of time. And the time is 4 years. So it's 1.025 to the power of 4. And we're going to multiply that by the original amount. And the original amount was £560. Now, we know money has 2 decimal places, so we need to make sure that when we are writing our answer, we're giving at least 3 decimal places to show our rounding. So 1.025 to the power of 4 multiplied by 560 gives us 618.135, and we're going to round that to £618.14. Now, the question's asking us to calculate the compound interest, so we need to work out how much of an increase there is from 560 to £618.14. So we're going to do that by working out £618.14 take away £560 and no pence. So we're going to have 14 pence, we're going to have £8, and then we're going to need to borrow it to work out that it's £58 and 14 pence is my compound interest. Now, if you don't remember the shorthand way, you can always work it using the long method. So after year 1, we're going to have our original value, 560, and we're going to multiply that. And this annual rate as a decimal is 0.025. So we're going to multiply that 560 by 0.025 to get £14 profit or compound interest at the end of the first year. Then we need to add that £14 onto the 560 before we can start looking at how much compound interest has been made in the second year. So we're going to start off with £574 and we're going to multiply that by 0.025, and that gives us compound interest in year 2 of £14.35. Again, we need to add that £14.35 onto the £574 before we can see what the compound interest in year 3 is. And so we're going to start off with £588.35 at the beginning of year 3 and apply our 2.5% interest. And that gives us 14.70875. And it's important not to round in the middle of these calculations. Use the answer button on your calculator. And so finally, in year 4, we're adding that on, and we're starting off with 603.05875 multiplied by our 0.025, and we're getting 15.076, and then some more numbers on our calculator. And if we add that £15.08 on to our £603.06, we would get the £618.14. But we're not really interested in how much we have at the end of 4 years. We want to know what that compound interest is. And so we're going to add our numbers that we have made at the end of each year. So we're going to have our £14. We're going to have £14.35. We're going to have £14.71. And we're going to have £15.08. And if we add them all together, we're going to end up with £58.14, which matches what we got using the shorthand method. So our next example, Miss Bricks brought a Ferrari from old Mr. Bloggs for £2,250. The value appreciated at 12.5% per year. How much was it worth after 5 years? So, procedure is start with 100%, add on our percentage increase. It's appreciating, so we're adding on. So it's 12.5. And that gives us a new percentage of 112.5%. We want to make that into a decimal by dividing by 100. So we're dividing by 100, which is 1.125. And we can check that we've divided correctly, because if it's appreciation, our number should start with a 1 point something. We're then going to take that decimal, 1.125, and we're going to put it to the power of time. And the time in this particular example is 5 years. So it's 1.125 to the power of 5. And we're multiplying it by the original amount, and the original amount that Miss Bricks bought the Ferrari for was £2,250. Now, if we put that into our calculator, we end up with 4,054.573, and we need to round it to 2 decimal places because it's money. And so after 5 years, the Ferrari was worth £4,054.57. So Miss Bricks got a pretty good return on her investment. Depreciation is when there's a percentage loss over a period of time. So this time we're starting with our 100%, but we're going to decrease it by subtracting the percentage decrease. And then the rest of the steps are exactly the same as they are for appreciation. We're going to divide by 100 to make it into a decimal. We're going to take that decimal to the power of the time in the question, and then we're going to multiply by the original amount. So in this example, a John O'Deere tractor was bought for £14,500. In the first 2 years, it depreciated by 15.1%, and in year 3, it depreciated by 18.3%. What was its actual value after 3 years? So you can see that we've got 2 different depreciation rates. One of them is over a period of 2 years, and the other one is over a period of 1 year. So we're going to look at the first 2 years first, because we need to know what the value was at the end of year 2 before we can apply the depreciation for year 3. So we start with our 100%, and we're going to take away the 15.1% because that is our percentage loss or percentage decrease for the first 2 years. So we're going to take away 15.1. and that gives us 84.9. We're going to take that 84.9 and we're going to divide it by 100 to get our decimal, which is 0.849. Now, if it's a depreciation, our decimal will always start with a 0, because if it was greater than 1, then it would be a percentage increase. So we need to take that 0.849 and we're going to put it to the power of time. And the power of time for the first rate is 2 years. So it's 0.849 to the power of 2, and we're multiplying that by our original amount, which is 14,500. And that's going to give us 10,451.6145. And I'm not going to round it because I'm going to be using that figure in year 3. So for my next depreciation, I'm going to start with 100 again, and this time I'm taking away the 18.3%. And that gives me 81.7. I'm going to take that 81.7 and I'm going to divide it by 100, and that gives me 0.817, and I can double check that it makes sense. It's less than 1, it's depreciating, so it makes sense. So I'm going to take that decimal and I'm going to put it to the power of time. Now, the power of time is in year 3, so that's 1 year, so I'm going to have it to the power of 1. And then I'm multiplying it by the value that I created at the end of year 2. So I'm multiplying that by the 10,451.6145. And that gives me a value of 8,538.96905. And I'm going to round that to 2 decimal places. And that's going to give me £8,538.97. And that is my actual value after 3 years. Now, there is a shorthand method that you can do if you have more than one rate. Once you've worked out your 2 decimals and you've got your periods of time, so I'm going to highlight them on the equations that we created, then you can put everything into one step. So we can say that we've got our 0.849 to the power of 2 multiplied by our 0.817 to the power of 1 multiplied by our 14,500, and it will give us the 8,538.969, which we can round to give us £8,538.97.